Okay, I am here today to explain to you how to compute a population sample, this the sample population from the actual population using the Slovin's formula. Okay, a lot of the students ask me to present an actual computation, an example of an actual computation on how to do the Slovin's formula. If you recall from our lecture in statistics that there are two types of statistics. There are descriptive statistics and inferential statistics. Now, inferential statistics will require a sample population because, number one, it is just too impossible to conduct the survey or to conduct the questioning or giving out of handling out of questionnaires, or to conduct the test or the experimentation to the entire population when the entire population is really big, when there are so many people or subjects involved. It is just too big, it is just too time consuming for the researcher to implement their survey or to conduct their experimentation. And because of that, you will require to get a sample from the actual size, from the actual population. You will get a sample, a small group of people selected from the actual population, and these small group, this sample population or this sample group will now be your basis to represent the entire population. Let's just say, for example, you want to know how many girls in Humboldt High School are fans of Taylor Swift. Okay. Now, Humboldt High School is one of the biggest high schools in California, and of course, they're a very big high school, their population size is also very big. Considering that you want to know how many girls, okay, are fans of Taylor Swift. Let's just say Humboldt High School has a population of 1,600 girls. Just imagine, if you want to know how many of these girls think that Taylor Swift is cool, how many of these girls think that Taylor Swift songs are very amazing, how many of these girls think that Taylor Swift is amazing, do you have the time to interview 1,600 girls? Or do you have the luxury of computing the responses of 1,600 girls? And since you don't have the time, you do not have the luxury of time, and you do not have, and of course, you do not want to exert so much effort to identify how many of the 1,600 girls think that Taylor Swift is cool, she's amazing, she's talented. So you are just going to get a sample population from the 1,600. You're not going to interview all 1,600. You're not going to distribute 1,600 questionnaires. You're not going to interpret and measure and check the responses of 1,600 girls. This is for you to save time and lesser work. Okay. However, the results of the responses of the 1,600 girls could be most likely similar. Okay, I would say 95% similar to the responses of the sample population that you will get from the 1,600 girls. Now, you just do not come up with numbers. You cannot just say, oh, okay, I'm just going to get 100 girls. I'm just going to interview 100 girls. And whatever the responses of the 100 girls, that will represent the 1,600 girls. That will be like 90% similar to the responses of 1,600 girls. Do you think that's possible? No, it's not. And that's why we will use the Sloven's formula to be able to identify exactly how many from the 1,600 are you going to get as your sample population. How many of them? How many of the 1,600? Okay, so Sloven's formula is defined as n equals, who can recall? Come on. Equals, you have n, 1 plus n 0.05 squared. Okay. What is this? You might be wondering what's the n and what's the 1 and what's the 0.05. Okay. N is your total population. Oh, let's change this one with a small n. Okay. The small n will be your sample population. Okay. This one is, we call this one the margin of error, meaning the percentage of error. Because since you are not interviewing all 1,600, you are not questioning all 1,600, you're only getting a portion of the 1,600 and interview them. So you cannot really say that the response of the sample population is exactly 100% the same with the response of the total population. No, it cannot be, since you're only getting a sample. So there is a percentage of error. And this time, your percentage of error, or your margin of error, is what? Is 5%. That's why 5% is equal to 0.05. Now, the bigger your margin of error, the smaller your sample of population. But again, the chances of a bigger margin of error, that means the assurance of your answers may not be similar, or may not be 95% similar to the 1,600. You can have, so I'm going to show you that one later. Okay. So for example, let's compute. You have 1,600, that's your total population. And this is 1 plus 1,600 times 0.05 squared. So 0.05 squared is how much? It becomes so it becomes 1,600 divided by 1 plus 1,600 times 0.25. Am I correct? 0.25? No. It's 0.025, I believe. 0.0025, that's correct. I made a mistake, 0.0025. So it becomes now n, 1,600, 1 plus, let's get our calculators out, 1,600 divided by 0.0025. Hang on. Point. So you have now, oh, hang on, 600 times point 0025. So you have now 1 plus 4. So therefore, your n will be 1,600 divided by 5. 600 divided by 5. Then that means you will only interview 320 girls. So instead of interviewing or asking 1,600 girls and finding out how many are they who like Taylor Swift, you don't need to interview 1,600 girls. You don't have the time. And it's too much effort. You just need to interview 320 girls. And you will most likely get the same percentage of responses with the 1,600. Although the responses of the 320 girls is about 5% wrong compared to the responses, the perfect responses of the 1,600 girls. Now, I said that you can increase your margin of error. So let's just say you increase your margin of error. Your n becomes 1,600 divided by 1 plus 1,600 times 0.05 squared. That will be 1,600. 1 plus 1,600 times 0.0025. That becomes, oh no, sorry. Since we're going to increase it to 10%. Since we're going to increase it to 10, let's just say 8%. 0.08 squared. So 0.08 is equals to 0.0064. So 1,600 times 4 is equals to 10.24. So 1 plus 10.24. So you will have now 1,600 divided by 11.24. 1,600 divided by 11.24. Now you will only interview 14 girls. Wow. Just imagine. From 1,600, you're only interviewing 14 girls. But of course, your margin of error is 8%. So the bigger the margin of error, the lesser the number of people that you will be interviewing. Okay? So this is it. This is just the basic and how you compute Slovin's formula. Now, why is it Slovin's formula? Number one, Slovin's formula is the easiest way to compute a sample population, especially in social science and in business research. Number two, Slovin's formula is not just easy, it also gives you a chance to balance, to identify your margin of error, whether you have a 5% margin of error, a 6%, a 7% margin of error. Again, the bigger the margin of error, the smaller the sample population is. But the smaller the sample population is, the farther away the responses are to the actual responses of the actual population. So I hope we are able to clear this one out. If you have any questions on how to compute the Slovin's formula, you know where to catch me. Call the office, set an appointment with me, or send me an email to my email, allainfonte@wcuniversity.edu, and we'll discuss it from there. So, yes, so hopefully I get this clear this one out. Thank you very much, everyone. Have a great day.